So those are all fun things. I want to take a look at the program in this way. Let's see here. So here we have the program, and what does this program do? Let me ask you, how would you characterize this program's operation? What is it doing?
You mean as far as just generating an infinite maze?
Okay, there's one person weighs in saying it's generating an infinite maze. That sounds like what it's doing.
Art a line at a time, almost like a tessellation.
It has an interesting visual effect, certainly, and it seems to me that part of that. I mean, let's see. Let's just break this program and let me remove one thing. Let's imagine we have basic version 1 from Dartmouth. The semicolon is introduced in basic version 2. The semicolon is a typographical mark, of course, but it indicates here the way in which the print statement will be formatted, that instead of moving to the next line, you will produce the next thing that you're printing right up against the last thing that you did. So if I take it out, I get that. It's somewhat less appealing. Michael, do you want to write a book with me about this? Probably not. Okay. Right? But that's just one character of difference right there. And I think that the fact that that looks different is very useful to think about, because what makes this program interesting is that a one-dimensional process of selecting the left or right diagonal line, which is fairly uninteresting by itself, is wrapped into a two-dimensional process that produces something else visually. Okay? So this is one of the things, is this shift of dimension, something that computers do that is fairly interesting. It's also iterating. Obviously, the go to 10 simply does the same thing as a while statement with a condition that's always true. Anyone notice anything unusual about how it's scrolling up the screen?
Scrolls 2 lines at a time.
Yeah, so here it moves up 2 lines and then fills in. It moves up 2 lines. The Commodore 64 screen is 40 characters wide, but there's an 80-character logical line, right? And you're seeing the visual result of that in how this program runs. And of course, why is there an 80 characters that comes up by default in our terminal still that we use, right? Why is that? Where does that come from?
Typewriter?
Hollerith cards.
Hollerith cards. Yes. Yes, they have 80 original punch cards pre-computer, have 80 spaces on there. So we again we're seeing these constant traces of computing's past that remain in these ways, and we love to imagine abstraction as something that takes us away from all of this and gives us the purity of the way that computers operate. But in fact, they're full of different sorts of cultural ghosts in this way. Now, one of the things, I think it seems to me pretty evident that it's these 2 characters in particular that make this so interesting, right? That if we just substituted, for instance, like a space and a capital letter A, that we would not get like a very interesting pattern, right? So if I go up and change this to some other value, okay, you know, it's not bad, but I don't see that I have quite the same. When this is produced, questions don't come to my mind like, can I solve it? You know, my eye doesn't race along the passageways. It doesn't seem to have as much visual interest. And so one thing I might want to know is, well, are there other adjacent character combinations that might do the same thing in the C64? So I could look, well, there's all sorts of ways I could do things. What I'll do here is so I can see. I'll just modify the program so that I'm going to use the a random value, which it prints out at the beginning. So here's 173 and 174. That's what those characters look like. That's sort of
Textural.
That's sort of cool. There's a lot of them that are interesting, sort of textile, you know, type of patterns. Oh, we've already seen that one. There's another one. Okay, I'm going to make that stop. Here's
Yes. Jackpot.
yeah,
Centipede.
possibly. I think we're about to find the city of U. All right. Yeah, so what the point I want to make about doing this, so this is an interesting sort of weave pattern, right? I don't find it as compelling as the maze pattern, but you can see that like it looks like rattan or some type of interesting pattern. It's suggestive of something else, or some of the others aren't, right? The reason that I want to introduce this very quick exercise is to show that it is possible to actually do our thinking, our humanistic, cultural, and interpretive sort of thinking about computer programs by writing computer programs, or by modifying the computer programs that are there. And I think it's more obvious in the case of this example because this is a program that is explicitly presented for us to modify and for us to play with and for us to learn from, in its earliest form, which was the Commodore User's Guide of 1981, although there it was presented as a 3-line program rather than the program that we see. All right. Okay, so we've taken a look at that. One of the things I want to, I'll just mention here also, that call to ran 1, these are 2 different emulators in which I'm running the program, and I do this here to show you that it's deterministic. Actually, ran 1 produces the same sequence when it's invoked on any C64. The thing that is random about it is not that you get a sequence that would be a surprise to you if you'd seen the ran 1 sequence before, but rather that each individual number that comes up is less, is not particularly easy to guess, right? So, so here we have, and in fact, it's rather useful. We could have done something that reseeded it based on the time, with just giving it a negative argument here instead of 1. But this is a good way also to talk about the way that randomness works in computing. And it's a good thing, actually, that our random-like generators can be seeded and can be made to produce the same sequence of values because we can test them, right? It's not a problem. It's not like a pseudo-random. It's a pseudo-random number generator? That's like fake randomness, isn't it? No, it's not like that. Actually, it's useful to have that, right? And here we see an example. This is the appearance in July 1984 Run magazine of this program. It's hex 93 here. Dan Kruger of Cary, Illinois writes, amazing one-liner. Here is one of the best one-liners I've ever seen. It works on the VIC and C64 and the PET, incidentally, drawing a continuous maze that is very interesting. And then there's the program itself. And then he notice in introducing this, he already mentions like how to modify it to make it do something else. To get random colors on the C64, add char string 149 plus rand8 times 11 just before the semicolon, right? So when you're given this program, you're also told one interesting, cool way to modify it, right? And there's a lot of interesting things about seeing this. I mean, we don't think about computer programs really as being transmitted in print. Although we can still find books, the books are still being published that have computer programs in them that you're invited to type in and try and learn from and so on. But they were transmitted in print, and even I think you can also step not too far from this particular statement here and see that people may have memorized one-line programs and shared them with one another. And so rather than thinking about magnetic media, the internet, as exclusively the ways in which these programs had circulated, there are these other sort of folkloric and cultural ways. And the occurrence of these programs in magazines is certainly not, of this one program is not a fluke. There are many like this. In fact, this is a section of the magazine, the magic section of Run, which is dedicated to tips, tricks, and one-line programs. And you see some other one-liners up there for the bit. So here's what we have in this program. We got a program that actually is not interactive. It takes no user input during execution. Doesn't have comments or variables. We don't know who wrote it. It wasn't Dan Kruger. He says this is the coolest program, one-line program that he's seen. You know, he basically declaims having written it in his note that he sends in. It doesn't really have a clear purpose or category. I mean, it has some pedagogical use. It can dazzle people, so on. But you know, if you were trying to choose, is it like productivity, antivirus? I mean, it's not these things, right? And it doesn't have more than one line, right? But all of these things are what we can investigate based on this. Iteration, 2D effects from 1D processes, randomness, character graphics and character sets, which I'll get into in a bit, basic and high-level languages, platform's role, and the transmission of programs, and then how mazes and patterns exist in culture and what we think about them. So what I'm going to talk about now is something that actually that Warren has given us a great deal of help in formulating, the idea that we might port programs as a method of understanding these programs. So this is also something I'm going to talk about a little bit in my talk tomorrow, possibly, but with reference to different systems. Here's a program by Warren, actually, which is a JavaScript program to do approximately the same thing. But you can see that the output doesn't look much like what we had before. There's a very wide spacing between lines, a proportional font, and the way that the kerning is done means that things probably don't line up, although it's hard to tell because these things are so far apart. It doesn't look like a maze. But you can express this program concisely. It's sort of, one of the things also it proves is that, you know, this isn't somehow like a fluke of the BASIC programming language, that like BASIC was written around a program like this so that you could produce an online program. No, you can do it also in JavaScript. Right? You could do it in Perl. Again, we might imagine, I might have adjusted my terminal somehow, but I mean it doesn't, we see that here things line up using a monospace font, but it still doesn't look so great. We could try it in a contemporary, more or less contemporary computer. This is a Apple IIgs emulator. Actually, no. This is will emulate an Apple IIgs, but this is a 2E that I'm emulating here. And we have character string 47 and 92 are the two different characters. They're not adjacent, so we have to do something a little bit different. But we can still write a one-line program. It's a little harder. We can still write that. However, again, when we run it, we see, I mean, these / and / characters are, you know, perfectly diagonal. I mean, these are characters that are on the grid here. You've got diagonal lines, but it still doesn't look very much like a maze. So what you get from that is the awareness of how it is, of how important that character set, those specific characters, even though forward and backslash exist on many, many different platforms, is to the effect of this program. And of course, it was also nice that those characters are adjacent. But this shows that, you know, even though you can write something very similar in BASIC on a contemporary computer, you're not getting something that has the same punch and the same visual output.